Without any further ado, let me get to presenting. Also, it'll be a little shorter than advertised. I hope that's okay. So stream to mock, how streaming helps your staging environment and sandboxes stay up to date. So the ideal type of person attending the webinar is somebody that is working with a type of service that they're testing, and they might have a test environment or sandbox environment of it, and perhaps that's deployed in the same cluster as the real environment, which is getting more and more common in Kubernetes type deployment. So I'd like to talk about how streaming helps with that. Some of you might have used Kafka before to maintain sandbox and staging environments. And some of this will touch on that, but I'll talk about how Flink can help with that as well. But before we get to that, I'll talk about the agenda. So first, why mock at all? Why create a mock of your service? It's not at all obvious. I'd like to talk about that. Then a brief history of mocks, so how mocking has happened in the past. Then tools to mock without streams, there's plenty of them, and maybe some of them you've already used, and if you have any suggestions, I'd be happy to hear them. Then mocking with streams, the first of which that I know of was done with Meeshkan, which my company built in Apache Kafka, and then our brand new strategy, so mocking with streams and state. And this has been possible with Flink for a while, but it's been massively easier with the new state APIs that were released that some of you folks know about, and that I'm personally very excited about in Apache Flink. So first, why mock? A couple stories from the dark side of what happens when you're testing and you don't mock stuff. So my favorite one, it's a true story. A microservice sent a text message from a staging environment to a real customer saying, "I want you back," with a little heart over 20 times a day. So somebody in their test environment had accidentally put a production credential for Twilio, and then was testing sending out text messages, and sent one to a real person for every time their CI/CD pipeline ran. So that's one good reason to use a mock. Another really good reason to use a mock, and this is another true story, a Cucumber test verified an emergency alert is sent when the table is accidentally deleted from a database. And they accidentally ran this test against production. So it was constantly deleting a table in a database, and then sending a test alert, even though it was deleting the production table. So that's pretty bad. Yet another reason that you want to use staging environment or mock in your test. And then another one that I've seen before several times, a team's API drifted so far from their Swagger spec that they decided to stop sending the spec to consultants and just ask them to figure stuff out from production logs. So if you don't have a really good airtight staging or mock system, then it's very easy to have some other artifact like a spec, but then the spec is like created usually once during a burst of enthusiasm, but then it's not necessarily maintained or updated, and it leads to this concept of drift. Another thing I'll say is that a lot of these things are quite time intensive, and later on we'll see how doing it with streaming automates a lot of this process. But I think that one of the reasons that people don't maintain mocks or staging environments is just because it takes time. And like if you're working for a business and they're paying you to develop and ship features, it's not necessarily something that is done often on company time. And of course, that's understandable too. Sorry, I'm a little too eager in my slide flipping through. So mocks allow teams to test their services and integrations with confidence. So if you have a mock version of your server or a mock version of your downstream dependencies, and the mock is quite good, then you can confidently say, these tests that I've run, I'm happy to ship this production code because they're run against a mock that represents in the highest degree possible what the production environment will look like. So a brief history of mocks first. So in the beginning, there was production, meaning there were no mocks. So if you think about the earliest systems that were deployed in the 40s and 50s computing systems, I'm thinking about if you built a giant refrigerator-esque vacuum cleaner-backed computer to run something, you didn't build a second one. You just had that. And you would work with it, and when you were testing stuff out, it would be with that machine, and it would break, and then you didn't have production anymore, and you would fix it. So There used to be no mocks, no staging, no anything like that. There was just production. So then, next step, then came the first mock, the staging environment. So people making production systems got a little bit easier, perhaps in the 70s and 80s, and then people would build staging environments for several different reasons. One was to gate features as they went to production. So something would go to a staging environment, hang out there for a while until people were happy with it. And happiness is defined like because it would pass some tests or because it would because it lived in staging long enough where people would like it. And then if enough people were happy with it, it would get promoted to production, usually by some manual means. And sometimes stuff would just linger and hang out in the staging environment forever. Sometimes it was a feature that was only meant for the staging environment. So this is kind of the next type of mock, and this is still, I would say, the most common one. So many of you that are at this webinar, if you're working in a company, you folks might have a staging environment and might test stuff out there before you test it live in production, which is a classic and very reasonable workflow. But staging environments had their problems. So they're monolithic. So don't expect anything reliable to be there if you're testing things out, as your colleague may also be using it. I've seen flame wars about staging environments where somebody deletes somebody else's staging data that they were relying on to do some type of test or development, and that could be pretty bad. So of course, deleting production data is worse from a business outcome perspective, but deleting staging data can be quite bad from a processes perspective, which then ultimately affects business outcomes. So staging environments are monolithic. Another problem is drifting. So staging environments, I find, frequently fall out of step with production. And then lastly, they're difficult to deploy, which makes CI/CD really cumbersome. So the next thing we'll put in the history of mocks, and this is all, by the way, going towards streaming and eventually Flink, but I think it's just important to state this out. So containers. So containerization helps mocking and testing. So tools like Docker and Kubernetes allow developers to spin up and tear down ephemeral versions of their stack on a per test basis. So no more monolith anymore for the staging environment. They're not heavy. Doing the hello world in Docker is a matter of milliseconds now. Always theoretically in line with production when using Ansible, Terraform, or there's proprietary ones too, stuff like Azure, AWS. So containerization helps you have a mock version of your infrastructure that way, but there's still issues. So containers do not know anything about downstream dependencies, so it makes it really hard to mock and work on containers that depend on a robust ecosystem of services. So it's pretty rare these days that in Kubernetes, for example, you'll have nodes that don't interact with other nodes that are standalone. In fact, that kind of defeats the whole purpose of Kubernetes. So usually pods are tied together in a, sorry, I said nodes before I meant pods. Usually pods are tied together in a Kubernetes stack. And because of that, it's pretty hard to mock one of them in isolation just by containerizing it. Then containers can't start in an arbitrary state without ad hoc logic. So when you spin up an ephemeral version of your stack, whatever the persistence layer is starts in like tabula rasa mode, which for a lot of your tests, you might not want to test what your infrastructure is like when it has like no users or no clients. Usually you want to test it out when it's kind of alive and kicking. That's one of the things we'll see later that streaming solves best. But so we're still in containerization and we find that's an issue. And then containers have no inherent service discovery mechanism. So it's really tough to know what to test, meaning if you have a microservice and you want to bombard it with calls to like do fuzz testing, or you want to do some type of property-based testing, you need some sort of Docker spec that tells you what's inside the microservice. There's service discovery mechanisms that ship that you can put in Kubernetes. So essentially you create a service mesh and then service discovery becomes a little bit easier with stuff like Istio. I don't know if any of you folks use that. There's a couple other options too, but inherently containerization has no native idea of service discovery. So that makes testing really hard unless you yourself are the one that has written the service, or you're very familiar with the documentation. But usually that's pretty clunky, especially if you're working in an organization with lots of people that need to get up to speed fast. So at Meeshkan, the company I work at, we solve these issues by mocking services recording streams of their I/O operations, which is usually some type of API, usually REST, and using the streams to reverse engineer an accurate mock of the service. So I say reverse engineer because if you have around, let's say, 100,000 inputs and outputs to a REST API, you can come up with a really good Swagger spec for how that API works from the inputs and outputs, because they represent the domain of possible. Usually, of course, there's corner cases that the server might not test out. But then it gets to the philosophical question that if a server never runs a piece of code ever in production, then is that part of the spec? And I would say no. So by recording all the inputs and all the outputs from a service, you have a very good picture of how it works, which means that you could reverse engineer something that's quite reliable. And the reason that I talked about streams of their IO operations as opposed to just recording the IO operations is it would be indecent, as many of you could imagine, to record, to store all of your databases or all of your services requests and responses in some type of data glacier. I have friends that work at Netflix, for example, and Netflix is seeing billions of requests and responses a day. If all of those were stored ad infinitum in a data glacier, then that would consume like the planet's databases, data centers within like a day or something like that. So streaming is quite important for this when you're talking about reverse engineering something from its inputs and outputs. Even streams have the problems, and Flink actually solves a lot of them. So I'll get to that in a little bit, but I just want to bring up the idea that you can create a mock service instead of building it with something, instead of like building the mock service by reverse engineering it from its inputs and outputs. So let me rewind a little bit and first talk about mocking without streams. So there's several ways to do mocking without streams. Some of these might seem quite familiar to you. So first is in-memory mocks, which is one of the most early and still common ones. So JavaScript has libraries like unmock, knock, poly. Python has libraries like Pook, HTTP pretty. Go has HTTP mock, and Go mock can be used for that as well. So benefits of these in-memory mocks is that they allow programmers to co-locate application logic and test logic. Certain frameworks like Unmock, which shameless plug, my company also develops, allow for fuzzing and property-based testing. So instead of testing one outcome of interaction of server, you test n, where n's usually quite large, for free by having a good spec. And if you don't know about property-based testing and fuzzing, be sure to drop me a note. That's a little outside the scope of this presentation, but it's a pretty cool concept. And then their in-memory mocks are very light to set up because they're in memory in the program that you're running. But they do have their disadvantages, and they're falling increasingly out of fashion for several reasons. So one of the benefits, like I said, was that it allows programmers to co-locate application logic and test logic. But this is not necessarily a benefit. It's also a downside. So I find that these days, a lot more business stakeholders are writing tests than are writing code. So for example, if you have a project manager or even a C-suite executive that wants to ensure that the offering that's being presented by their clients actually complies with the way that they're talking about it, then it's very attractive for that person to be able to write a test, which winds up being a contractor spec that states, I believe that my product works this way. And then if there's any drift between that and the way that it actually works, then that can become a subject of discussion. So more and more stakeholders are writing tests, which means that if you co-locate the test code with the actual code, it limits the number of people that can contribute and might not be the most optimal outcome for your business. Another problem of in-memory mocks is that it's difficult to transfer to other languages because they're written in the language of your software. So if there's ever any refactoring into microservices, then you also have to refactor your mocks, which is not a deal. They require lots of manual maintenance as services evolve. And then maybe the most problematic one is it tends to bloat tests with logic, which defeats the purpose of testing, as you have to test your tests. So if your mocks are in memory, and especially if they have some type of if they're mocking also some type of database persistence, then your testing code can get really big, out of control really fast. And as one of my favorite testing gurus, Yogi Goldberg, states, tests should be really simple, like really, really simple. It should be, tests are essentially like a little robotic user that you unleash on your code. And if you want your service to be simple, then the robotic user should do simple things. So testing should never become unwieldy at all. A much more attractive option, in my opinion, is mock servers. So Meeshkan, which is soon to be renamed Mem on GitHub, Hoverfly, WireMock, and Prism. These are all excellent mock servers. The benefits of them is that they separate testing from mocking, so at least a smaller test, so you don't need to write any of the code in your test because the servers are actually in the mock. They can be shared across repos, and they're usually light to set up. So the strategy that I find that is used most often is that if you have like a Helm file, you can boot up a mock version of your server instead of the real service whenever you're running a test, and then boot up the real service in production. So I think that's a pretty attractive outcome when you're running tests. So there's several frameworks that I mentioned, like WireMock, Meeshkan, and Prism and Hoverfly. But the issue with these is that mock servers are really, really, really hard to keep up to date. So if you're using WireMock, for example, and you have a service that sees about 1 million requests and responses a day, then managing the fixtures or the mocks that go into WireMock is you have to come up with some type of ad hoc logic where you're going to store those things. How often are you going to create a new mock service? What even constitutes a correct mock service? Meaning if there was a bug in the server for 3 days, how do you get rid of whatever requests and responses were generated when that bug was present? There's all sorts of issues that come up in kind of the real world that don't come up in toy projects where you just like record 10 requests and responses and then create a mock server from it. So they're really, really, really hard to keep up to date. This is why mocking with streams is really attractive in my mind. And we haven't gotten to the Flink portion yet, but I'm guessing that if a lot of you are Apache Flink users and you're kind of interested in streams, then you've probably used Kafka too. So this part, the first part will be about that before I get to why I think Flink is a better alternative. So how mocking with streams solves the mock server problem. So when you're ingesting tens of millions of requests, which if you're using Flink, then your server probably is ingesting tons of requests because otherwise you wouldn't need a solution like that. Mocking based on stored fixtures is simply not an option. You can't put them anywhere. You don't have any throttling or any of the nice things that comes along with a streaming system. Then another nice part about mocking servers based on streams is that streaming systems generally, and this is true, of course, of Kafka and Flink, have some type of windowing or rewinding. So it allows you to test against arbitrary snapshots of a service. So testing against snapshots of a server is a little bit like git bisect. So if you've used git bisect before, it's one of my favorite ways to find bugs. And let's say if there's a bug in your service, one of the first things that I want to know is when did that thing pop up? And then you'll rewind your service using git bisect. It can show the exact git commit where a bug came up. So git bisect works because you have access to your source control. But if you're doing mocking where you're dealing with downstream dependencies, you don't have access to a mock server. So you kind of only have half the equation. And the nice thing about working with streams is that if the stream layer, if the data tenancy is long enough in streams, then you could actually use different parts of the stream to create a mock server. So that means that, for example, you could use 7 days worth of stream data to create a mock server from like how a server worked from Monday to Monday, or you could rerun it Sunday to Sunday or Saturday to Saturday. And if the server doesn't change, then mocks will be the same. But if, let's say that a new feature is introduced or there's a certain type of bug, you'll have a different type of server, which means that when you run the test, there might be different outcomes. So it's a similar thing as git bisect, except instead of rewinding in time in Git repository, you're rewinding in time in the way that your server worked. Which, if you're trying to figure out why a bug was provoked, that can be a lifesaver, I find. So that's why I like working with streams. So first, a little bit about mocking streams with Kafka. There's a really cool article on dev.to. So how to do this mocking using Meeshkan. I would encourage you to check it out. That article is about Kafka. So the input, let's say in your Kubernetes cluster, you have a Meeshkan node that is ingesting data, which is the way that this article is written. So the input is requests and responses that are going to a microservice, and the output is a mock server. So you can consider it a small node in your Kubernetes cluster where the input is requests and responses, and output is a mock that's reverse engineered from those. And that's what's used when you run your tests. So that's kind of the 10,000 foot view of how you could create mocks with Kafka, but there's a big problem with that. It's really hard because it requires a stateful service that retains a large window of data that's transformed into a mock server. So if I want to, if I'm confident that the last 3 days of data are all I'll ever need in order to create a mock version of my service, then mocking with Kafka totally makes sense. But I find that as services evolve, there are behaviors that might be provoked only once in a blue moon. And if that's the case, then it's really hard to have data tenancy that lasts long enough to encapsulate that behavior, which means that your Kafka, the window of data that's kept alive has to be really long, which is like, of course, really inefficient for any of you that have used technologies like that before. So one way to get around this, and this is kind of the reason that many people migrate to Flink in the first place, is because you need some sort of stateful streams. So Flink solves the state problem in service mocking. So now think about the same flow, but tweaked a little bit. So Meeshkan, again, remember Meeshkan, the input to Meeshkan is requests and responses from a server in some type of logging format, and the output is a mock server. So Meeshkan's deployed to a stateful function of Flink. If you're following Flink news, then you saw the most recent release about stateful functions. I think they're pretty awesome. Definitely check them out. Thank you very much to the Flink team for developing this. So it's deployed as a stateful function. The stateful function keeps the current mock as a state. So it will keep the mock server that's currently deployed as a state. It ingests a certain window of recordings and outputs a new mock server based on the diff between the way the old one works and these new recordings. So that's a kind of a common model in any machine learning type-based flow, that you have your model, you have some new data, and then you update the model with that new data and make a new model that's trained on that. In a way, I mean, under the hood, Meeshkan is using NLP, but it's no different. In this context, you have a model, which is in this case your mock server. It's a model of your server. And instead of retraining it on a whole lot of data, you train it on just a new little bit. So the way that we used to do this is that we would store these mock servers in like these, basically on S3 or in some type of persistence layer where you store files, but it's pretty hackish to do that, or rather not hackish. It just takes a lot of extra steps and it is prone for error. And Flink just abstracts that all the way under the hood, like really, really nicely. So basically you get your new requests and responses in, you get the state retains your mock server, and then you have a new service out that's hydrated or augmented with these new requests and responses. Another added benefit of this that I'd like to draw to people's attention is that if the new mock and the old mock are not the same, so remember the state is the old mock and it's producing a new mock, so you could compare the two of them. If they're not the same, an alert can be set that the service has drifted. So this is really important, that if you're writing your test in a certain way because you assume that your downstream dependencies are going to behave in a certain way, and if all of a sudden you get an alert that the mock service that you're running your test against has changed, it might require no alternative at all, but it might be nice to know, okay, the service that I was depending on, Flink has told me that when it made a new version of it, it was different than the old one that it retained in its state, and that means that my downstream dependencies might function in ways that I wasn't expecting, so I might want to be extra attentive to that, or maybe even write a couple more tests. So that's a pretty nice thing, just from a human aspect, that those types of alerts are possible. And then one thing I said before, but it bears repeating, is that creating a mock from a diff obviates the need for long stream retention. And that's when you're dealing with tens of millions of requests and responses, it doesn't make sense to keep that much data. And another thing I should say is that logging all of the requests and responses that go to a server can slow things down catastrophically. So a lot of times you're sampling anyway. So this allows, if you're sampling, then it increases the window of time even more, so that makes statefulness even more attractive in building your mock servers. So one last and kind of shameless plug for the company that I work in, Meeshkan. So if your company is deployed on Flink and interested in building mock servers for testing using streams and stateful functions, definitely reach out. All of these tools for open source are available on github.com/Meeshkan, and we have an automatic testing commercial product too that's at Meeshkan.com. But in general, I love to chat about this sort of thing. The article that I put in these slides, it's already really useful, so that'll get you up and running. But I'm happy to chat about it as well. Just on a personal level, I'm very excited about Apache Flink and very excited about the new evolutions with stateful functions. So thank you to everyone. As I mentioned, this was a bit shorter than advertised, just because of a little timing snafu that came up with a calendar invitation.